Welcome to Nordson Electronics here at Apex 2026. I'm delighted to be joined by Gordon Liu. Nice to see you, Gordon.
Nice to meet you, Trevor.
Yeah. So we're standing in front of the Easycoat coding system, which you've had for some time, but you've made some significant upgrades to,
That's right,
which
yeah.
we want to talk about this week. So let's start off perhaps with the software system.
Right. So after last year's Apex, as well as some feedback from some other customers, one of the new things we've been working on in the software-wise is what we call the 3D visualizer. And it's essentially a feature that lets customers upload their own 3D CAD files directly into Easycoat to use for offline programming.
Okay.
Because I think a big complaint was, well, we had the 2D image before to help with programming, but we didn't know like how tall certain components are, right? So this will give the users the ability to have that information when they're working offline.
So they can see if they're actually getting full coverage on a tall component.
Right. It's really to make sure like we're not going to like crash into anything, right? And you can see how the coding will interact with like taller components that you couldn't detect on a 2D view.
Right.
Yeah.
Right. Okay.
Yeah.
So what about for like keep out zones and certain things? I mean, you know, people want to obviously have tight definitions. They're not wanting to do. They want to do as little masking as possible.
Right.
What sort of things are you doing that can help with that?
Yeah, I think, you know, one of the features of Easycoat is this masking feature here. So it allows people to really quickly define keep out zones on their parts, right? And then that way they don't have to spend so much time like detailing it. I think when it comes to avoiding masking, you know, it really depends on the type of material you're using as well as the board design itself, you know. So sometimes if the board is very compact and all the components and keep out zones are very close to each other, it's sort of hard to avoid, you know, material wicking over into those keep out zones.
Right.
Yeah.
Right.
But we try our best at Nordson to give the users the tools, you know, to be able to avoid having to manually mask as much as possible.
Okay. Okay. Now, one of the other things that you've incorporated into the machine is a flow meter, or you've improved the flow meter.
That's right.
What have you done to it?
So the new flow meter that you see there is our non-contact flow meter, and it's, like I said, another innovation based off of feedback from our customers. So this system still gives you that same traceability that you had with our old flow meter systems, but with the added benefit of not having to worry about your flow meter getting contaminated or damaged, right, from having coding running through it all the time.
Okay.
Yeah. So this system.
So how does it do that? I mean, how does it? Depends on what sort of material you're putting through it.
Yeah, so essentially the flow meter, you just clamp around the fluid line, right? And I think it uses ultrasonic to sort of measure the flow rate fluid going through it. Yeah.
I see. I see. Excellent. Okay.
Yeah.
And that can be measured and controlled from the same interface.
Exactly. Yeah. So the flow meter is actually plug and play, right? And so you not only do we have the new flow meter available, you still have access to all of the same process control that we normally offer, right, with our flow meters in the past. So you can control, you know, how much volume you want to make sure you're putting down your board. You can have it send out alerts, right, if you're exceeding or dropping below whatever limits the user sets. So we have that control available as well.
Excellent, excellent. Well, that's a couple of major upgrades to the Easycoat system. Gordon, I want to thank you for showing us that. We're now going to move to the other side of the Nordson Electronics booth here to look at a couple of other machines with the new upgraded SQ5000. So here we are at the other side of the Nordson booth, and we're at the test and inspection area. And I'm joined by Ahmed Khan. Nice to see you, Ahmed.
Nice to see you, Trevor.
Okay, so you're head of test and inspection here for Nordson. So what have you got that's new this week?
So Trevor, first of all, very nice to see you again.
Thank you.
We have a couple of new additions to our portfolios. One is on the AOI, Automated Optical Inspection. We have a platform right behind you, SQ5000. This is the first time we are showing here in the US.
Okay.
And alongside that, we have in our X-ray division, we are also launching an X3 X-ray automated inspection machine as well.
Okay, and who's going to be showing us these different machines?
So I have my colleagues with me today. I have Kyle Vendeshav. He is going to be showing the AOI, and then we have Andrew, our applications engineer from the XRT division, and he is going to be giving you a live demo of the X-ray machine.
Excellent. Okay. Well, thank you very much, and I look forward to joining Kyle and talking about the SI. Thank you. Thank you. Hi, Kyle.
How are you
I'm going
doing?
to pass this to you. So we're standing here in front of the SQ5000. We've had the SQ family around for a little while.
Yes.
So what are the upgrades?
Yeah, well, first off, it's a whole new platform, so it's a little bit different than the version 1 SQ5000. It's going to have linear encoders that are the higher resolution, so it allows us to move the sensor a lot faster. So that really helps with cycle time, increasing throughput for the
and
customers.
accuracy, I would think.
And accuracy as well, yeah, better repeatability.
Right.
And it also has a whole new sensor. So the whole sensor architecture is the same that we had previous success with on the SQ3000. This is now just a larger field of view, so we can cover more ground per field of view and per shot. Helps with throughput as well as better cameras. So there's going to be repeatability there, and also the RGB values. It's going to have better resolution. Same 3D resolution, so the recipes for our previous customers are still transferable.
Right.
Now we've added new software capabilities as well, whereas you can train new 2D images, but with the 2D images, you're going to be adding a lot of AI that's involved with that.
I see.
So that helps.
I see.
Yeah, recipes are transferable, and then you get better throughput. And we have now color side angle cameras too. So if you look inside connectors or any weird things from tall capacitors on the side reading the markings, you can do that with the side cameras instead of a white and black image as it was before.
Great. So I mean, what sort of size of camera have you got in?
So it's a 50 square centimeters per field of view, and then we have the same architecture. So we have a top-down digital light projector and 4 side angle cameras, and they're all still powered by our MRS technology, that multi-reflection suppression.
Right.
So we're really known for having good 3D renders, filtering out the bad data, keeping the good data, helping reduce those false calls. We can generate that height map in the 2D image and manipulate it in multiple ways.
Right.
We do also have a top-down coaxial illuminator, so that can make shiny dye appear really bright. And find chip outs, cracks, things as you get smaller and smaller.
Absolutely. Yeah. So what size are the cameras that are the 4 cameras that are around the edge?
25 megapixels, so you can kind of combine that as well.
That's
and
quite a lot of capacity.
So this is our high-speed camera. We also have a high resolution, so we go from the 9-micron resolution to 7-micron resolution. So we still have that 30-millimeter range down to a 10-millimeter height range, so you're capable of rendering with it. And then it's on the Z-axis, so we can move that up and down and change that focus position. And we can capture multiple focus positions and then pull those together in a focus stacked image to present to the customer as well.
That's an awful lot more data you're capturing, so there's a lot more data crunching needed. You've increased the compute power within the system.
Yes, so that GPU performance and that advancements in that field, that we benefit from that too. So that really helps with our processing power, being able to compute all that data, and the height maps that we're able to generate, we can actually export that for our customer as well. So they can use that, and then that'll help them in our dispensing team, so they know not to interfere during that dispense process as well.
Right. Well, a lot of changes into the system. So thank you very much for showing us it today, and we wish you every success with it.
Yeah, appreciate it. Yeah, we're excited to offer it.
Yeah,
exciting stuff. The future, it's looking bright.
Thank you, Kyle. So we're going to take a wander across now to speak to, I think it's Andrew, who's on the X3 X-ray system. So now we're back over at the X-ray side of Nordson's test and inspection, and I'm joined by Dr. Andrew Mathers. Andrew, you actually run the X-ray side of it, so welcome, and
thank you for having me.
Tell us a little bit about some of the key changes that you've built into the X3 X-ray system.
We're seeing a real trend in the market right now towards 3D imaging. Typically, applications that only required 2D or 2.5D, where speed was absolutely paramount, and 2D was much faster than 3D. We've now got a much faster approach to 3D, which we're terming Dynamic Planar CT. This brings the speed right down to 3 seconds per field of view, and in our future systems released later this year, this will now decrease to 2 seconds per field of view. So it's really closing that gap to the speed of 2D imaging, but giving much richer detail and 3D volumetric information.
Absolutely, and that's so important in an inline system, which traditionally we haven't been able to get great resolution out of these systems. But I mean, I think getting that improvement is certainly important. Now you talked about planar CT. Can you explain a little bit deeper how that works compared to other types of systems?
Absolutely. So planar CT is typically on a planar object, which is typically very thin, very flat, like a PCB, for example, or a semicon strip. They're quite challenging to image, particularly if you're talking CT imaging, because traditionally in a CT system you would spin the object around 360 degrees and keep everything fixed. Dynamic planar CT actually moves the sample in X and Y, and the detector does an orbit underneath.
I see.
So we're able to capture much richer information in the Z direction, which is typically where laminography, a form of computed tomography, suffers due to artifacts.
Yes.
So Dynamic Planar CT is a big step forward past planar CT, our former 3D approach. We get much richer detail, much better layer separation. And when you're looking at something that's, less than a centimeter thick, that layer separation is crucial because we're looking at very small components which inside themselves have very fine features, voids, cracks, delamination, non-wetting solder. So being able to visualize that very clearly between the layers without ghosting from components above and below is really important.
Yeah, that's important. And as you said, some of these other systems do use ghosting to sort of join the dots, as it were, but it's not really that accurate. You've also increased the board size because, I mean, here in North America, of course, we've got 5G, 6G coming down the roadmap. We've also got all these boards from data centers, which are carrying large components. What have you done to sort of address that market?
Well, we've seen this market grow quite rapidly, not just here in the Americas, but also in Asia as well. And we're also seeing a need for it in Europe. So later this year, around the middle of the summer, we're looking to launch our first large board AXI system. That'll be able to handle samples up to 820 millimeters by 660. This is this real push towards AI server boards, as you mentioned, but also the 5G telecoms market. A lot of this is focused around big, large PCB or extra large FATP samples, which have got very tall components or a lot of layers. So having greater clearance, greater inclination angle for 2.5D as well, to be able to inspect them with off-axis imaging, as well as dynamic planar CT, which we just spoke about, is going to be super important. It's an area that in the past we haven't focused on as much, but we're seeing a real need for this in the market now, and of course we're following suit, and we're looking to bring out a highly competitive system to serve that market.
Well, it's certainly coming out at the right time because it's ramping up pretty fast. Finally, you did some work on improving the programming capability of the system. I wouldn't say it's fully automatic yet, but it's semi-automatic at least. So can you maybe tell us something about what you've done at that end?
Absolutely. Ease of programming is something that is needed everywhere at the moment. Traditionally, AXI systems, and to a certain degree the MXI as well, have been very detailed. There's a lot of options. There's a lot of fine-tuning that's needed to get the very best images. We're absolutely committed to making this easier for the operator. We hear this in all regions, that ease of use and programming is an absolute must. It somewhat reduces the amount of training the operator needs to use it, and with an automated system, you're not meant to be in front of it all day, every day, setting things up. So anything we can bring to make that system easier or more intuitive and easier, we absolutely focusing on that and committed to improving that for the future.
Especially in Europe and the US, where you have a lot of high mix and stuff like that, it's very important.
Yes, indeed. Nobody wants to spend a very long time setting up a program and fine-tuning it. People want to get a board in the system, get it set up and go. Well,
Andrew, I wish you every success with the new machine when it comes out in summer. I want to thank you for talking to us today about the improvements we've already made to the X3.
Brilliant. Thank you for your time. I appreciate it.
Thank you.
Synchro. Join the revolution. Non-stop selective soldering. Increase UPH. Reduce maintenance. Small footprint. Contact us today.